Everyone, my name is Anish Jha, branch CY. Today the subject is ADA and the topic is selection sort. The topic today is selection sort in C programming. Let's go through the contents of today's topic. Introduction to selection sort, how selection sort works, implementation in C programming, analyzing selection sort, practical applications of selection sort, common issues and debugging, and finally conclusion. Let's go to the first topic, which is introduction to selection sort. Overview of sorting algorithms. Definition of sorting. Sorting is the process of arranging data in a specific order, typically ascending or descending. It facilitates efficient data management and retrieval, making algorithms like selection sort essential for optimizing performance in programming tasks. Understanding sorting helps improving algorithm design and data handling strategies. Importance of sorting algorithms. Selection sort is a fundamental sorting algorithm that emphasizes simplicity and efficiency for small data sets. Understanding its mechanics enhances comprehension of sorting principles and lays the groundwork of more advanced algorithms, highlighting the crucial role sorting plays in data organization and retrieval. Types of sorting algorithms. Selection sort is a simple comparison-based algorithm that divides list into a sorted and unsorted region. It repeatedly selects the smallest or largest element from the unsorted region, placing it at the end of the sorted region, making it intuitive yet inefficient for large data sets. What is selection sort? Definition and concept. Selection sort is a simple comparison-based sorting algorithm. It works by dividing the input list into sorted and unsorted region, iteratively selecting the smallest or largest element from the unsorted region and moving it to the sorted region until the entire list is sorted. Characteristics of selection sort. Selection sort is a simple comparison-based algorithm that works by repeatedly finding the minimum element from the unsorted portion of the array and moving it to the beginning. It has a time complexity of big O to the n to the power 2, making it inefficient for large datasets, but is easy to implement and understand. Comparison with other sorting algorithms. Selection sort is an intuitive and straightforward algorithm, yet it's inefficient for large dataset. With a time complexity of n to the power big O to the n power 2, compared to algorithms like quicksort and merge sort, which have an average complexities of big O to the n log n, selection sort is less suitable for performance critical applications. Now let's on to move to the second topic, how selection sort works. Step-by-step explanation. Finding the minimum element. In selection sort, the algorithm scans the entire array to identify the minimum element in each iteration. This is done by comparing each element with the current minimum, ensuring that after completing the scan, the smallest value is found for the swap with the current position. Swapping elements. Selection sort works by repeatedly selecting the smallest or largest element from the unsorted portion of the array and swapping it with the first unsorted element. This process continues until all elements are sorted, ensuring each swap brings the array closer to completion. Repeating the process. In selection sort, after each pass, the smallest unsorted element is positioned at the start of the unsorted section. This process repeats, narrowing the range until the array is fully sorted, ensuring that each pass places the next smallest elements in its correct position. Pseudocode for selection sort. Overview of pseudocode. Selection sort iteratively divides the list into a sorted and unsorted region. The pseudocode outlines the process step by step, finding the minimum element from the unsorted portion and swapping it with the first unsorted element, effectively expanding the sorted region until the entire list is sorted. Advantages of using pseudocode. Selection sort operates by repeatedly finding the minimum element from the unsorted position and swapping it with the first unsorted element. This method allows for simple implementation and easy understanding, making it a useful illustration for pseudocode to clarify logic and flow in programming. Detailed explanation of each step. Selection sort works by dividing the array into a sorted and unsorted section. It repeatedly finds the minimum element from the unsorted section, swaps it with the first unsorted element, gradually building the sorted section until the entire array is sorted. Let's move on to the third topic, implementation in C programming. Setting up the environment. Required software and tools. To implement selection sort in C, ensure you have an appropriate integrated development environment like code blocks or dev C++. Additionally, install a C compiler such as GCC for compiling your code and running the program effectively. Writing the C program. To implement selection sort in C, first set up your development environment with a C compiler such as GCC. Then write the program by defining the selection sort function, using loops for comparisons and properly handling array input and output. Complete C code for selection sort. Explanation of the code structure. The code for selection sort in C is structured with a main function for user input, nested loops for iterating through the array, and a swapping mechanism to rearrange elements. This clear organization enhances readability and showcases the algorithm's systematic approach to sorting. Code walkthrough. Key functions. The selection sort implementation in C utilizes a loop to repeatedly find the minimum element and swap it with the first unsorted element. Key functions include which enhances values and the main sorting logic that iterates through the array for proper ordering. Sample output and testing. The complete C code for selection sort effectively sorts an array by repeatedly finding the minimum element. Testing with various input arrays reveals that the algorithm performs consistently, producing sorted outputs as expected. Sample outputs showcase the algorithm's efficiency with both small and large datasets. Now let's move on to the fourth topic, analyzing selection sort. Time complexity. Best case scenario. In the best case scenario, selection sort consistently performs n-1 comparisons for n elements, regardless of the initial order. Thus, its time complexity remains big O n to the power 2 due to the nested loop structure, making it inefficient for large datasets even when they are partially sorted. Average case scenario. In the average case scenario of selection sort, the algorithm performs approximately n to the power 2 by 2 comparisons and n to minus 1 swaps, leading to a time complexity of O big O n to the power 2. This inefficiency makes it less suitable for large datasets compared to more advanced sorting algorithms. Worst case scenario. In the worst case scenario, selection sort consistently performs n-1 comparisons for n elements and n-2 for second, so on, leading to a total of n into n-1 by 2 comparisons. A time complexity of big O n to the power 2, making it inefficient for large data sets. Space complexity. In-place sorting. Selection sort is an in-place sorting algorithm requiring only a constant amount of additional space. It sorts the list by repeatedly selecting the minimum element and swapping it with the current position, thus efficiently utilizing the original array without needing extra storage. Memory usage analysis. Selection sort has a space complexity of big O1 as it requires a constant amount of additional memory space. The algorithm sorts the array in place using only a few variables for swapping, making it efficient in terms of memory usage even for large data sets. Let's move on to the fifth topic, practical applications of selection sort. When to use selection sort? Small datasets. Selection sort is efficient for small datasets due to its simplicity and minimum overhead. With big O to power n to the power 2 complexity, it performs adequately for lists under 100 elements, making implementation straightforward in educational contexts and easy to understand for beginners in C programming. Simplicity and educational use. Selection sort simplicity makes it ideal for educational purposes, helping beginners grasp fundamental sorting concepts. Its straightforward implementation allows students to focus on algorithmic thinking rather than complex code, making it a practical choice for teaching fundamental programming skills in C. Case studies. Step 1. Example scenarios. Selection sort is most effective for small, nearly sorted data sets where simplicity and consistent performance becomes advantages. For example, in educational tools, selection sort aids in teaching sorting concepts, while in embedded system, it maintains resources efficiency due to its low memory overhead. Performance comparisons. Selection sort, while not the most efficient for large datasets, demonstrates constant performance in small arrays. Its simplicity makes it ideal for teaching basic strong concepts in applications where memory usage is critical and the dataset is small. Its in-place algorithm proves advantageous. 6. Common issues and debugging. Common errors implementation. Off by one errors. Off by one errors in selection sort typically occur when miscalculating loop boundaries. For example, starting or ending a loop one index too early or late can lead to incomplete sorting or access out of array bounds. resulting in incorrect behavior or runtime errors. Careful attention to index limits is essential. Incorrect index manipulation. Incorrect index manipulation can lead to outer bounds errors or incorrect element swaps in selection sort. Ensure that the loop indices are properly initialized and updated to avoid accessing invalid memory or skipping elements during the sorting process. Always validate index ranges. Debugging techniques. Use print statements. Using print statements in debugging, selection sort can help identify issues such as incorrect array indexing or order of swaps. By strategically placing print statements before and after key operations, you can trace variables, values, and determine where the algorithm deviates from expected behavior. Utilizing debuggers. Utilizing debuggers in C for selection sort helps identify logical errors and incorrect index handling. Setting breakpoints allows step-by-step execution, revealing how the array elements are swapped and traced, ensuring algorithm correctness and insufficient debugging of issues like infinite loops. Finally, let's come to the conclusion. Summary of selection sort. Key takeaways. Selection sort is a simple in-place sorting algorithm that consistently finds the minimum element and places it in the correct position. Key takeaway includes its big O to n to the power 2 time complexity, making it insufficient for large datasets, but it offers an intuitive understanding of sorting principles. Final thoughts on selection sort. In conclusion, selection sort is a straightforward algorithm ideal for small datasets due to its complexity and ease of implementation. However, its inefficiency with larger datasets highlights the need for more advanced sorting algorithms in practice, making it less favorable in performance critical applications. Further reading and resources. Recommended books, online tutorials and documentation. Thank you. I hope you found it informative.